Short bit about me. I presented a 10-minute talk, I don't know, 2 months ago, and was asked to come back and talk about DNS in a little more detail. Wrote a pretty deep dive presentation and then bored myself to death with it and seeked feedback and kind of came full circle and built a workshop. We're going to register a domain name tonight and kind of walk through the configuring the bind utility to serve up a CNAME record so we can host a website. Cool. Encourage anybody to jump in at any time. I tried to integrate questions that we didn't get answered 2 weeks ago. My day job is at Merit Network. I spent some time in the NOC at Merit, and today I am a developer on the Route Asset Database project. And all of that, delivering the service, we had to, you have to become a DNS expert if you want to deliver anything high availability. One of the neat things that Merit does is run mini domains at mi.us zone. They are running just over 3,000 zones total. So it's kind of a fun infrastructure to work on day in and day out. Feel like any Linux presentation isn't complete without pointing out that my favorite scripting language is Perl, and my favorite editor is Vim. So we've got a short to-do list tonight. We've picked a DNS register, Name.com. We're going to head over there. We're going to register an arbitrary domain name, bbtab.com, for no other reason. And then we are going to delegate the hosting of that zone to 2 servers that we're going to spin up and create tonight. Pretty straightforward. We're going to do it all with bind. Lots of architecture decisions can go in. Bind is the implementation standard. If there's been an RFC written that includes DNS, bind has implemented it. Just because you can do it in bind doesn't make it a reasonable choice. Just because bind doesn't make it a reasonable choice. For DNS, your goal is really to keep it as simple and straightforward as possible. So that's where we'll start tonight. It'll look a little bit like this when we're all done. Hopefully that comes out a bit better. We're going to have our local laptop reach out to a standard DNS recursor, either the one provided by our ISP, Go Merit, in this facility, or one of the popular DNS recursor service would be Google's 8.8.8.8 or Packet Clearinghouse's and IBM's new 9.9.9.9, and OpenDNS is also popular. So we're the root DNS zone is already operated for us by some very brilliant people and distributed around the world in Anycast. They point to the .com registry, which is operated by VeriSign. We're going to go over to name.com, use their web interface to register for the zone, and then add glue records into the VeriSign.operated com zone. They're going to offer delegation down to our 2 servers tonight. I borrowed one from DigitalOcean in New York and from friends in Germany. So we kind of are going to have global coverage. The exciting part about DNS is as long as you have the same zone replicated to multiple machines, and you have the com zone aware of all of the delegated machines. They don't need to be in perfect sync. They don't need to talk back and forth. They're incredibly reliant and resilient. Routing will get you there. Your local resolver at every step of the way is querying one of any random number of root servers, one of any I believe there's 7 com servers, A through M. They're Anycast, so there's many more than that. Your machine's going to pick one completely at random, and then our resolver is going to pick one of our machines completely at random. So we'll see that a little bit we saw it 2 weeks ago or 2 months ago, and we'll see it here again tonight with some dig commands. So 2 servers. The fun part about tonight's speech is we're actually going to use the zone that we're registering to host the name servers. So they're going to be aware of themselves and each other and host everything else for the zone. If you've ever outsourced your DNS to another provider, you know, whether it be Amazon or Google or Name.com themselves, they run DNS servers in their zone, right? It might be something like nameserver1.name.com, in which case you don't have to add any glue record or do anything other than do the delegation. So we're going to kind of drop those A records, we're going to call them B records here in a bit, on the name.com server. So the name.com server is, or the name.com configuration is really super simple. You pay them $13 and they will happily give you a domain name for a year. It's not yours, you lease it. You do have the right to continue to renew it forever, but there are very few registries that will give you perpetual ownership of the domain name. Name.com, after you register, will come in with a list of default name servers that look a lot like this. Name server 1 through 4.name.com. So looks a lot like this when you get a fresh domain name. This allows you to use name.com's DNS architecture. You don't actually have to host your own DNS if you want to get up with a very basic website. But they're very non-performant and there's very little you can do for configuration access. So this is kind of what a default zone looks like from name.com. Then they give you a, and you can pick any register, name.com, Hoover, Network Solutions, they all provide the exact same offerings. And then they'll provide you a very, very simple web interface where you can come in here and you can put your own A records, you can create your own www name record, that sort of thing. We're going to replicate all of this tonight in our own infrastructure. So the first thing that we're going to do is we're going to tell name.com that, that we're going to operate our own servers. I chose the name of the two machines tonight, our NSDE for our Germany server and NSNYC for our server in New York. These machines can be shared. There's no reason you can't do this on your web machine or on your mail machine. So we're going to click the apply button, and this makes a very, very simple configuration change. By an APA call out to VeriSign, we have changed what's actually happening in the com.zone file. So now when we query VeriSign or when we query com., who are the name servers for bbtap.com, what we're going to find is that they're going to be delegated right back to bbtap.com. So we can jump over and see what that looks like. Machine we know works. So we quickly ran, we're using the dig command to ask DNS what's currently happening. The dig command is written by the folks over at Bind. We've issued a plus trace, which is a really nice way to walk the DNS chain, walk that chart from top to bottom. The first thing that we're doing is querying the dot servers, the root servers for the dot zone. We're asking them, hey, where can we get com? What servers are responsible for com? And then it returns this list of com servers. Our resolver picks one at random, so I'll pick one at random. And I'm going to dig at a server responsible for com. Yeah, that's how that works, isn't it? we're going to ask that com server, where are the NS servers, the name servers for bbtap.com? What we care about are these first couple lines. We've asked the servers responsible for com, which is gtl-servers.net. Who are the name servers, the NS at the end, for bbtap.com? This machine responded back with the two servers that we just set over on the name.com website. So at this point, VeriSign has delegated the bbtap.com zone to these two name servers. There's a little bit of a hiccup that's going to happen here that we're going to see, and that because the name servers are within the zone we're controlling, we have to send some extra information across. You can't yet go to these name servers and ask for the IP address of the name servers in the zone itself. VeriSign, the folks running .com at the moment, have to do that on our behalf. They have to send us a little bit of extra information. To make that work, we're going to go back to the name.com servers at Blue Records. But before we do that, let's jump over to our master name server. I'm going to elect the New York City server as our master, and we're going to go ahead and configure bind over on the New York server. So with the click of a mouse, we're going to end up over on a machine in New York. Thanks to the fine folks at DigitalOcean for reaching out and sharing some space. The bind config or install process is really, really simple. You'll want to grab, on any machine that you're hanging out on, you'll want to grab the bind down utils. It'll give you the latest version of Dig on your machine, whenever the latest version of Dig and some other stuff. I like to grab the documentation. Nice to have my every man page you could ever dream of configured out there. And the actual project that we care about, the bind service, is in the bind 9 repository. We're going to jump on into Ubuntu box, but it's available across any standard. And then we're going to edit 3 real quick files. Bind has a very simple structure. And the comp file that tells this local machine how to run is very simple, and it drops, for our sanity, breaks up key components into named.conf, name.conf's default zones, which we're going to leave alone, name.conf local, which tells this machine how to operate, and, name.conf options, which tells this machine how to operate, and then finally we're going to run load in name.conf.local, which is going to tell the machine what zones that this server is responsible for. Explicitly, we're going to go out of our way to tell our name server that it's not responsible for any other zones. We're going to be explicit that it should never answer for Google.com or Amazon.com. It should never do recursive lookup. Otherwise, bind, being a fully capable package, will go resolve that A record or resolve that quad A record for any question that it's asked. So we're going to, our first step is to tell this machine that it's only responsible for the domain names that it's configured for, which is a rather simple 2 lines that we're going to add to our options. Recursion no and allow transfer no. Recursion no is that very simple line item that says bind will not follow the recursion tree for DNS zones that it's not aware of, and will only provide authoritative answers. And then allow transfer will make sure that we're never transferring the entirety of a zone file to unknown parties. We're only answering the specific questions they have. So we'll jump into named comp and options. And we have our default config, which has very, very little in it. We'll drop our two new lines, recursion no, and allow transfer none. Pretty simple, straightforward here. At this point, bind is now a service running on our machine that doesn't have anything at all to do. We can prove that it's working by asking localhost so when we ask a localhost, we're actually going to ask the DNS service. We're going to use the host file to find localhost, and then we're going to ask the bind service for its own IP address, which is kind of fun. So here we get back exactly the answer you'd expect. So we know our bind installation is running. We know that it's configured properly. We know that our config loaded in. We're going to run an RNDC. RNDC is the bind control utility. We'll run an RNDC reconfig. We'll load that file that we just made changes into memory. Prove that bind is still working with our dig at localhost. Localhost will ask for the A record. And to make sure that recursion is off, to make sure that our local machine is not going to answer for google.com, we'll go ahead and try it. We don't get an answer back. If we remove our short request, we'll get back a very nice warning that recursion was requested but not allowed. So by default, your bind installation will go out, but now we've got it explicitly only responding to the zones that it knows about. You never want to be in a position where you're offering DNS to the world. One of the neat aspects about DNS is authority is always in the is always up to the machine that's answering. So somebody else can be any number of machines can claim to be authoritative for your domain. It's important that you follow that hierarchy to ensure that you find the machine that's truly authoritative. So you can spin up as many masters and slaves as you want. You can test them. You can play with them on your own. But no other recurser will ever check until it's in the DNS chain. So it's safe to spin up a new google.com zone for yourself and play, and that machine itself will think it's authoritative. You can ask it for answers, and whatever you populate it will return. But nobody else in the world is going to trust it because they didn't follow the DNS tree themselves. So the reason that I'm bringing that up is you can pop open any new VM, you can bring up a new machine anywhere and become authoritative for your own zone. And it's not until you change your DNS records, your NS records over at name.com and in your own zone file do those become effective. So we'll jump over to the actual configuration. This is pretty straightforward. The definition for what is a zone is very cool. We tell the server what the name of the zone is, which is identical to what we registered with, bbtap.com. We're going to tell this machine that it's its own master. We're going to tell it where the source data is coming from. This can be in a number of different sources. It can be a database. It can be SQL, no SQL. We're going to pull it from a flat file in bind notation, which is the most common notation that you'd ever see. And then we're going to, again, deny full transfer of that zone from anywhere. Bind gives us some really neat tools to make sure that we didn't screw up. The first thing that we're going to care about is named -check config. Named check config will spit out an error if we made any syntactical problems. So before we reload that file, before we reload that zone file into memory, before the service is actually going to play with it, a check comp will give us a general yay or nay. What you look like will pass and will load. So now that we've verified the entire chain of the configuration files, we can once again call rndc reconfig, and now the server itself will answer authoritatively for its own zone. It's going to fail because we haven't populated our the com.bbtab zone file yet, our flat file that's hosting the underlying data. So that'll be our next step. One of the tricks that I use, you can name these files anything you want. It gets out of control very, very quickly. I always go from a left to right naming scheme because you might want to delegate a piece of underneath your zone to another machine or to another set of services. This is most popular if you subscribe to a cloud service that wants to manage NS records on their own. You can in turn, there's some really neat Amazon AWS utilities that'll do this to you. Your zone file might have something like aws.bbtab.com is delegated to the Amazon name servers. Well, they'll deal with your A and AAA records for you. So I name my stuff left to right so that what's on the right is an exercise of the user for them to figure out what's next. It also makes it very easy to sort and find what you're looking for. If all of your files are named with your .com on the right and you're living in a multi-tenancy environment, it becomes nearly impossible to sort alphabetically because you'll have some things where are either third or fourth level deep. In this way, all of your com files stay together, all of your net files stay together, all of your k12.mi.us files stay together. So we'll go take a look at the default file that loaded for our localhost. It's a great starting point to look at a bind notation file. So we'll go back to our default zones. Here's where the configuration from our local file came from. Etsy bind db.local. We'll use that as a template to work from tonight. So we'll bind zones is where we moved to.
Be there twice.
Thank you. That's right. So I chose to name mine com.bbtab. So here's the template of a, is that readable?
Yeah.
That's better.
Here's what our localhost zone file looks like and what we'll modify as a base template. At the very top left is our default TTL. The time to live is an instruction to all boxes that will ever cache your DNS records how long to cache them for. You can do it on a per label basis, or you can just use the TTL at the top. So we're going to go ahead and set that down to 5 seconds, otherwise we'll run into some trouble later tonight as we're playing around. The next couple things are the mname, which is the fully qualified domain name of the master name server for this zone, followed by an email address and to reach the host master, the folks responsible for maintaining this zone file. It's very non-intuitive and is kind of up to the exercise of the operator, whether it's the person consuming the DNS or setting up the DNS. What format that looks in. It usually comes in the place of first part of an email address, dot replacing the @ symbol, followed by the fully qualified domain name. Again, it's not all that helpful. Dot has, or the @ symbol has a special place in the bind, the bind notation. DNS data is very well defined in the RSC. It's all binary and very hard to work with without the help of a few tools. Wireshark is a great tool if you ever need to dig into what's actually happening in the DNS world. Even for not packets, the whole Wireshark substool for DNS will look at binary data and turn it into a human form for you. So we've decided that our name server in New York City is going to be our master name server. Master name servers only matter to us, they don't matter to the internet at large. Master is the source of the data, not necessarily where the data is getting served from. And this is important to note because all DNS servers, in our case tonight the New York and the Germany server, are going to serve the data authoritatively and completely at random. There is no load balancing. There is no hierarchy, primary, secondary, master, slave from the perspective of the client, only from the perspective of those managing the name servers. So fully qualified. I'll jump on that term a few times tonight, and particularly insisting on the final dot at the end. Our machines will always assume that the label that you're searching for will eventually need to refer to the root servers, the dot servers. At the very top of the chain, when you're working in DNS, you have to be explicit and place it there. Otherwise, we'll go back to our origin statement, the @ at the far left, and our bind server will tack on our own DNS, our own zone name to the end of the file. And then we'll drop my email in here because I am the hostmaster tonight. The serial number is commonly written in the format of year, month, date, followed by a incrementing number. This isn't particularly important, but your serial number can only ever move forward and can't move backward, so whatever point you start with, you want to make sure that you're moving forward. I use the date function. You know, it's only there for humans, but it's easy to make sure that's moving forward. If you ever need to move a serial number backward, it's kind of a pain in the butt, and you actually exploit the fact that it's a, I think it's a signed 32-bit number, so you can actually roll past and come back to negative numbers, and then roll forward to come up to 1, 2, and 3 again. The retry, refresh, expiry define how other name servers should interact with this particular name server. The one we pay most attention to is the negative cache TTL. This instructs instructs this name server how long of a TTL we should apply to a name that we don't know about. So if somebody comes in and creates a record or keeps searching my machine for foo.bbtap.com, that'll always return a packet in NX record back, an MX record, NX being that that zone doesn't exist, that label doesn't exist. We want to make sure that everything in the chain caches that as possible, otherwise we put ourselves into a denial of service position. At the same time, when you're trying to bring up a new service or you're moving machines around, this is a great value to lower. So we'll do that again here tonight. So I talked a little bit about the DNS origin, which is this @ symbol that's facing on the far left. The origin defines is a function of the server we're running right now, and the fact that our configuration file loaded this flat file. Our origin is bbtab.com. So instead of explicitly calling out bbtab.com in this file, we're using the @ symbol. That one at the top is fine and will keep us all the way through this entire record. Zones can cross-reference other zones, which is why it's important to have that label on the left. We're simplifying it with that @ symbol. The first thing that we need to do is make the zone aware of itself. So this is the first NS record in the zone. We'll set it to our New York City service. And we're at our first fundamental head scratcher of how can you find yourself unless you define your own A record. So that's the next thing on our list. And I'm going to have to cheat and go look at notes. Grab our A record. But I made a mistake. The A record that we're setting is for the NS-NYC label. So, what are we saying here with our first two lines? The first line that we're saying is for our origin, for bbtap.com, the name of the name server, the NS record, is nsnyc.bbtap.com. The second line is our first label, our first entry. This would be the same as your www, your mail dot, or anything else. A record is the IP address of the name server itself. So we're changing from the origin to a different label. The label that we're typing in here is nsnyc, and we're giving it our A address. If anybody's up for it, you should ask your local librarian for IPv6. Always drop your IPv6 records in at the same time. We're here, we won't get a chance to see it directly tonight because this local network is not IPv6 enabled. But here for good measure. So at this point we have a zone file that defines our zone, defines one name server in the zone, and how to find that name server based on its IPv4 and its IPv6 address. I cheated a little bit. Our label on the left is always the same as the line above it. So our NS record belongs to our origin. Our origin is the @ symbol, bbtap.com. Our NSNYC label isn't fully qualified. We didn't put it down on it, so bind is going to do us the favor and apply and change that by the time it gets loaded into memory to nsnyc.bbtap.com.
So when you created you said you went to DigitalOcean to create a virtual machine that
Yep.
you were playing with?
Yep.
They allocated those two IP addresses to you, right?
They did.
The IPv4 and the IPv6.
Yep.
That's what you plugged in.
Yep. Same machines, same IP addresses that this machine has. Bind gives us a really neat tool to make sure that we didn't make any fat fingering. It's the named check zone utility. So we'll run that. Again, we can check the syntax of our file before we commit it to the machine. Here we here the arguments are pretty simple. Because the check zone utility doesn't have access to your conf files, you have to tell it what domain name you want to check against. So our bbtap.com, and then which file we want to syntactically check.
Those IP addresses don't match, do they?
No.
That's not what you have in your zone file.
Sweet.
Yeah, 185 something in your zone file.
Go cloud computing.
Yeah.
I'm sure I did something really cool, like, you know, play around with load balancers.
Or machine.
I had a machine to play with, so I'm sure
It's
I
all right.
made lots of changes.
Tell you what, it sucks being colorblind. I can't read that at all.
The red, yeah.
Everybody else see that okay?
Well, not okay, it's dim. It's,
Oh, I could never read that. I could tell there was something red there, that was it.
So we're going to run the name check zone utility against the bind notation zone file that we just
Okay.
created. So this simulates what the server would do as it was loading it into memory. It syntactically validated everything we just did. One of the cool checks that it just did is made sure that it had the ability to find all of the DNS records that we entered itself. So at this point, we load the file into the process. We're back to RNDC. We are going to issue the reload command of bbtab.com, and this will fire off an instruction to the bind service to reload this zone from file or database or however you have it configured. It doesn't give us any feedback that it was successful or not because it just fired off the command to do it. For the lazy who don't go check, for the lazy who don't want to go check logs, you can run it again and it'll tell you there's nothing to do. So kind of a quick way to make sure you're right. So now we can dig at our local host machine for the bbtap.com SOA record, which will print off that very first line that we typed at the top of our zone file, the SOA, the start of authority, and then it gives you some other information because we asked for it. We can ask for an A record, which we haven't put in yet. It'll come back without a response. It's empty. And we can ask this server, what other name servers are you aware of? And it's only aware of itself. So now we have so we'll go back to our diagram. We have a little bit of a disjointed problem here. The COM files, or the COM zone servers, are sending us over to NSNYC. But how do we find NSNYC in itself? There's a recursive problem. because you can't go ask yourself for your own A record unless you know that IP address to begin with. So these are called glue records. They're simple A records inserted into the COM zone that are exposed to us in the web interface. Every provider makes this very difficult, and most of their support department doesn't know what in the heck we're talking about. So you'll have to hunt around. Before you make a domain name purchase, read the documentation and make sure this feature is exposed. Otherwise, you're in for a bad. Yeah.
Or stick with registrars that your friends have registered their domains through and say that they support glue records.
Yes, knowing that support glue records is all that you're after. Yeah, ask the mailing list, ask your friends, start somewhere helpful. Here we'll notice that we're already sending people to the wrong server, so we're going to go ahead and fix that.
That's the right one.
Oh, that's the right one?
174 is, yeah.
7068.
Yep.
7068.
The 185 that's bad, the one up above.
That's a different server. That's our Germany
Yeah, that's
server.
the Germany one.
Oh, okay.
So we haven't got there yet. I did short circuit this because who knows how quick the API to the VeriSign is and how quick they are to publish and things like that. So I did do this ahead of time. Usually it's instant, but it'll catch you when it's not. So we'll go jump over on another machine somewhere else. This is in Southfield, and we'll dig at the COM servers, the servers responsible for COM, asking for the NS records of bbtap.com. Tell us which machines are in charge. The COM servers now have our New York City and our DE name server, and they're returning this additional information. The COM servers recognized the predicament that you're in, so they're just going to send you some extra records. You asked for the NS records, and they're going to send you any corresponding A and quad A records for that as well, so that your local resolver can do that lookup for every other record. Does that little bit of magic make sense? Just a tiny little bit of
Bootstrapping the name server.
That's exactly what we're doing, is we're bootstrapping the name servers. So now we can do some pretty neat things. For starters, we should be able to get our A record of the New York City host itself from anywhere in the world. So here we go, we got our A records. It followed the DNS chain beginning to end. Again, we're on a host in Southfield, Michigan, completely disjointed to everything. And we're able to get back the A records for the zone itself, the A and the quad A records. We'll ask it for the Germany records. And because we haven't put them in the zone file yet, we're going to get back an error. Our error is ZX domain, that name doesn't exist. So, we have our first zone. Updating our zone is pretty straightforward. We'll add back into the zone file. And all of this is pretty lame if we're just hosting the zone ourselves. Most people will want MX records or www records or things like that. So we'll go ahead and make this something useful. We'll add a www record. We'll grab it from I'm going to point a CNAME at a web hosting provider for simplicity. And I think we left myself a nice little note. Make sure I got that right. Again, fully qualified domain name. This is the first gotcha that a lot of people run into is when when folks delegate CNAMEs from a domain they control to another domain control. They forget this tiny little dot at the end. If you forget that dot in the end, the bind server is going to append your zone is configured in the conf file back to the end. So it would tap on dbtap.com at the end. And while we're doing that, to demonstrate that, we'll go ahead and drop that from the DNS records since it's unnecessary. We'll do our RNDC reload. And when you don't specify which zone, it's going to reload every zone in the system. And at this point, back from our machine in Southfield, we can ask for the www record. And it will walk that DNS tree. It'll eventually drop us on our New York server. It'll return the CNAME record for our web host, and then it'll repeat the entire process to go get the IP address from their zone. So it's kind of fun at this point. We actually have a working website. Nothing exciting to see here, but kind of fun to see the entire DNS chain work from beginning to end. But we're entirely dependent on one host, or one DNS host, and staying up and being available for every other service, even if our mail is in the cloud, even if our website is in the cloud with a host somewhere else, we're still reliant on that one name server. So we can instruct bind to automatically fetch and update the each other's records. So we'll jump over to our host in Germany, and we'll do just about the same thing we did on the other server, without really changing much at all. The only difference is we'll replace the type of server from being master and grabbing it from a flat file to a slave, instructing it to grab the data from a master server. This is the only concept of master and slave. Clients aren't aware of this at all. They'll query one machine at random. Almost identical to our last config. We should jump over into our global options. Is the same place to remind the server that recursion is not allowed, and that we shouldn't allow our zone to be transferred out of here, any zone to be transferred out unless we're explicit. We'll jump on our local and we'll place our slave configuration in. So now we're kind of at an interesting point. When we're on any box other than our master server.
You don't want the name of the file in there, do you?
I do. So the one of the neat things about bind with the name of the file is that when it goes and fetches the entire zone file from the other server, it's pulling that across in a binary blob, and it's going to. What?
The first line of what you just pasted in
Oh.
is the file name you don't want.
Got it. Thank you.
Is that what you were talking about?
Yes. That
So,
is another second.
this file name is kind of cool. This other file name, as we pull
Oh, I
that
see.
master
Okay.
zone, or as we pull that zone file from the master to this machine is going to keep a copy of that file. So even if its own service crashes, even if this machine reboots, it can come up with a previous cache copy of the old machine, or of the data from the master machine. So that's what this file is. But you're right, I didn't mean the upper file. So here, we can dig over at our name server in New York City for the we'll grab the www record. We get back our www answer. But if we try to do a zone transfer, just like any other machine in the world, our zone transfer is going to fail. AXFR in the AXFR is a special type label, like an A record that gives you an IP address, or a quad A record that gives you an IPv6 address. AXFR is interpreted as transferring the entirety of the zone file from the machine that you asked for. There is also the concept of IXFR, which is an incremental transfer. That really doesn't apply when you're in the dig utility. Here, our primary name server, our master name server, happily gave us the CNAME. It happily answered our query, but it refused our transfer. One of the reasons you want to refuse a transfer by default is because you don't want to be used as part of a DNS reflection attack, where somebody queries you and you're sending a big answer to somebody else. And the other reason that people try to refuse zone files is they don't necessarily want to advertise the entirety of their namespace to the world. There's a couple really public zones that will offer you everything in AXFR. Namely k12.mi.us will not any longer. Just because, it's a public demonstration. So usually these machines will give up the entire A record. We'll have to
Somebody upgraded.
we'll have to see if our security folks disagreed with my position on that. That's a bit of a surprise to me. So very simple. We'll go back to we're back on our New York server box. We're going to edit our config file. Find from allow transfer of none, we'll add the IP address of the server over in Germany. We'll load that new config in. And we'll be back on our server in Germany. And we will request the entirety of that zone file. Live demonstrations. We got 'em. This is a fun transfer failed.
I think the syslog on the New York server, see if it shows
Oh, you got the wrong IP address. You got the 180,
Yeah.
that was the 185 address.
Yeah. 185, 206, 187. 185, 206, 187.
Does reconfig reload the zone file? finish the options file?
That's a really good question. I wish I knew.
I always just use reload, I didn't realize it probably isn't loading the options file.
Nope, nope, reload, only reloads.
I
the
rarely
zip file.
ever change the options file. Maybe it didn't reload your options.
I was hoping to see a typo.
Yeah, so try RNDC reload on New York.
Reload the file too.
Well, you want to reload the zone file, because you changed something in the zone file.
I haven't changed anything in the zone file yet, because you want to make sure that replications work.
Well, you changed the allow transfer.
That was in named.com. Allow transfers in named.com,
Okay.
which RNDC reconfig should take care of.
Is your Germany-New York connection going to press IPv6 first?
Probably. You know, that is something that is easy
Seems
to
like,
check.
Your Germany server has the New York IPv4 address, and it's configured.
So this was my local resolver that was looking up the address of the IP for the New York server on the Germany server. Was doing the IPv6 by default. Thank you.
Ah, I see, yeah.
So, very cool. Very, very neat. So we're on the Germany server and we've requested a copy of the entire zone file from the New York server. This is a binary stream of data that comes across that gets reinterpreted back to something executable, readable in the bind notation for humans on the new machine. You'll notice that any of the spacing has been completely lost. The capitalization will stay on the way through, but any comments that you make, anything that you leave behind for yourself on that other machine won't make it across. This is copy and pasteable, ready to go into a zone file if you ever need to make a recovery or move a client to a new machine. But one of the really neat things that comes across is the very first line and the very last line of the transfer are the SOA records in its entirety. There's a couple purposes for that, and that's to make sure that your DNS implementation, if it wasn't bind, if it was something else, didn't make a change somewhere while you're requesting the zone file. You'll know that you got a snapshot in time between the last serial number and the current serial number. And in this case, they match. Our serial number came across here. The second thing that does is it makes sure that humans can't copy and paste this and put it in a new zone without thinking about what they're doing, taking that last line off, which is kind of neat. Bind will always finish a transfer before it does a reload, so you don't have to worry about data in between changing while you're making the transfer. But other name servers have been known to, which is why we've adapted this SOA line at the beginning and the end. So over on this machine, it's pretty straightforward to bring it up. We'll do an RNDC reconfig to bring that new config file into play. We'll do an RNDC retransfer to grab the zone file over IPv4 from the main machine. Oh, you're right. You got to specify what you want retransfer. So now this zone file is loading in this machine. Bind transferred the file over, and then load it into memory so we can dig at localhost or the www.dbtab.com CNAME record, and it'll go ahead and return it for us. So now this server is keeping a copy of everything that we do over at the last machine. Bind does some really neat short-circuiting for us. So now when we're back over on our master to us, the server administrator's machine, and we jump into our zone file, and we tail the log file of our machine in Germany. This machine.
You know, fire log, it's just like this.
Thank you.
It's just like,
Is this log by default?
I think so. That's right, you do it.
Sure enough. So when we're over on our New York server and we make a change, like adding the fact that we now have a new NS record, a new name server,
That's not. Yeah, it's incorrectly under New York, but it's the same IP address and that's weird. So that complicated.
so we've made a change. Nothing has, we've made a change to a flat file. Nothing yet has happened in New York, or I'm sorry, in Germany.
Hit enter a few times here to, yeah. So when a change does happen, it'll be obvious.
So we'll.
You change the serial number?
Didn't, because I've got an audience.
Because he wants to show what happens when you don't.
So that's actually really interesting, when you don't change the serial. So over here, we'll run our RNDC reload. Again, successful just says, that we reloaded the whole machine. Reloaded every zone file. We can be more specific. Over in Germany, something really neat just happened. Our New York server sent a notification that a change has been made. That's a very simple packet, and advertised what the new serial number is. Then when the bind server in Germany has time, it initiates the transfer and pulls down the entirety of the zone file and reloads it into memory and then serves it up. So now from any machine, grab the one in Southfield again, we can dig at, say Google for a list of bbtab.com's name servers, and it will print out both of them. We can ask the New York server for both, and we can ask the Germany server for both. So that change made it all the way through. excuse me, that change made it all the way through. And now we have two name servers that are responsible for keeping each other completely up to date. And now we have a multi-county or multi-country network diverse set of name servers. Not much more going on there. So I think this is kind of a good breaking point to ask questions about DNS architecture or what we want to see demonstrated. I know there were quite a few questions last time we met about how you do X, Y, or Z, and I think now we got a whole infrastructure to take a look. So,
I've got a question.
yeah.
The way you've got it configured now, if you were to change, you don't have an IP address for your www server, you got a CNAME, but if you were to change that right now,
Yep.
how long before that gets propagated out to the network?
So there are a couple different things, and we can go ahead and do that. So I did a CNAME just to be dynamic, right? We can grab that IP address of that host because it's not going to go anywhere. We'll be on our master server. We'll jump in here, we'll replace the CNAME with an A record. And that IP address. So there's a couple things that are going to happen. The first thing that's going to happen is this, as soon as we commit this server in New York is going to issue that notify to the Germany server. And the Germany server is going to pick up that change when it can. And there's no real definition of when it can. That's up to the sysadmin to configure and make sure that machine's performing. So there's a very brief period of time where your name servers could be serving up different records. There's also a very real possibility that your remote server or multiple servers, it's reasonable to have between 6 and 7, unless you're doing some IndyCast stuff, and then maybe you only want 1 and 2 in IndyCast everywhere. Your new server won't expire the data out of its cache until this, well, it doesn't expire it out of the cache until some few days later. But the refresh line in your SOA is when the remote servers are going to check back in with your master server to see if anything's changed. So in addition to always listening and waiting for the notify, your remote server is instructed by the master server when it should come back in and check again.
So Germany would check with New York after 600,000 seconds? Is that what you're saying?
604,000 seconds. Yep, that's right.
The remote server,
Yep.
the Germany server.
Yep,
Okay.
if it misses the notify, and if there's not an administrator over on that other server to issue a retransfer,
Right.
that server will check back in and make the transfer again then. So that's kind of the first wait. If everything goes well, that first thing happens near instantly. And then what we care about is the TTL on the label of the zone itself. In our WW record example,
Okay.
we've got our 5 seconds up here. Usually this is set anywhere between 5 minutes and 1 day.
Okay.
The really tricky part here is that's the TTL in every cache from every recursive server operated by anybody in the network, including your machine itself. So they can add up if the server itself does it decrement. So we'll take a look at, we'll actually set this to something reasonably high so we can see it count down.
Yeah, change your serial number too.
Thanks, guys.
You just want to make sure we're paying attention.
Yeah, it's a group demonstration. So we'll do our reload of just the zone. We sent the message. We don't even know when this machine's picked it up. Without going and checking the log files, we won't know when this machine's going to cheat.
It's happened.
Run it again because it's already happened. We'll bounce over to Germany. We'll see that it's happened. This is kind of interesting. Multi-machine with multi-IP addresses. This time the reload came from the IPv6 address of New York, so the notify got rejected by the Germany server. So that's kind of fun. So you'll want to make sure that you've got a multi-master configuration inside your IPv4 and your IPv6. Since we don't want to wait around for our 600,000 seconds, we'll do our NDC retransfer. It's already done. And we'll grab a machine somewhere else. So here we are back in Southfield. We'll use the full dig command to ask we'll ask the Germany server.
Put an X-ray in it, BBA.
For the A record. And we'll see that our A record came back with a TTL of 30 seconds. We can continue to ask this server, and that TTL will remain at 30 seconds because it's the authoritative server. There's no reason for it to cache any further, so that machine's not decrementing that count. If we go and we ask the Google resolver, it's going to come back with 30 seconds because this is the first time that Google's seen it. So we get an instant back of 29 seconds, so they already shaved the second off the time. If we wait a few seconds and we hit the same Google server, which we won't because it's Google, and this is such a small zone. We'll grab a different server that I know will decrement it. We come back with our 30 seconds because it just looked it up. This machine is actually kind of cool. It recognized that my query was identical, so it replayed the packet back instead of searching its local cache value. So what can I do to influence this? Okay. Yeah, there we go. A big A would did it. So that was kind of cool. Resolver1.merit.edu, which is a resolver that's available in this library. Has a cache sitting in front of the DNS. If it recognizes an identical query packet, it will replay back the identical response packet. So that's why we saw the 30 seconds more.
How long will it replay that for? 30 seconds?
Nope, that's
The cache expired?
yeah, so it's a packet cache. In our case, it's as long as a matching request packet is in the cache, it will play back the matching response.
Regardless of what the TTLs are set at.
Or whether it's still right.
That's right, because that packet cache doesn't have any concept of what the payload is.
But isn't that breaking DNS because that packet cache doesn't know about TTL? So couldn't it return a result that is stale and has exceeded the DNS TTL?
Yes. Yes. Very much could break the TTL requirement for a very brief few seconds. The resolver one gets billions of queries per day.
I mean, yeah, it's a bit of an edge case to have such a short
So
TTL.
it works through that cache really, really quickly. It pretty much protects itself from getting hit by something that's gone wild really quickly. It's some you know, a fresh browser session, I don't know, I can't even come up with a case where you'd hit that cache repeatedly unless the TTL of the DNS packet was actually 0. So we cheated, we changed our packet a little bit by changing big A and small a. So now we're back.
There's nothing special about a big A or a small a, it's just different.
There's not, that's right.
Yeah.
My query
not
was
identical.
changed. You know.
Two different
Yeah,
commands.
it's not identical anymore, yeah.
It's not identical.
Yeah, okay.
It's not identical anymore. So here we see our 23 seconds. We saw it decrement a little bit. I hope if we wait again.
So it's not
There we
really a
go.
wall clock 30 seconds.
It is. It is a wall clock 30
It
seconds.
is, but we're getting them.
So here we go, right? Our cache expired and we're back to 30 seconds. I don't know, we've waited 3 seconds talking. I've influenced my machine to give us a
Okay,
different
9
record.
seconds, yep.
It's been
All right.
9 seconds. So this decremented a little bit. And we wait again. We see the TTL decrement every time. The local resolver is not going to go out and walk the entire DNS chain until that TTL value expires.
Mhm.
The interesting thing is you could almost guarantee that someone on the internet, probably the one person that you care most about, has a double cache in place. AT&T is known particularly they're particularly bad at the double caching. When you hit a local DNS server from your cell phone or your AT&T home internet connection, that DNS server goes and asks the main AT&T resolvers. Those resolvers walk the whole packet, the whole cache. And as far as I can tell, it actually believes the TTL time and will expire that record, but it's going to respond to your client with that entire original TTL. So the response back to your client in our 30-second example will remain 30 seconds, and that user's client will hold on to that TTL for 30 seconds. So things where you have your TTL set to a day, AT&T will happily cache that for 1 day, but they're going to give you the response that your authoritative server, they're going to give their clients the response that your authoritative server originally sent. And if that was sent to a day, then their machine is not going to ask again for another day from the moment they asked. Which
So it could be nearly 2 days.
it could be, in an edge case, it could be nearly 2 days. The safest bet is to make sure that your service is available on the old IP addresses and the old host names for twice the TTL. You know, it's relatively reasonable to run, if you're switching MX providers, if you're switching your MX records from one server to another, it's very reasonable to leave your old mail servers running for 2 days until that TTL completely expires. Or better yet, 2 days before you know you're gonna make a change,
Shorten your TTL.
jump in here and
Use your
lower the
TTL.
TTL.
Yeah, we did that.
Which is also a very reasonable thing to do on a per label basis. We can jump into our, so we still have our 30-second TTL there. We can set a TTL of 5 seconds for just our www record.
So you have the whole zone like a day.
You could have the whole zone a day. We're going to run our name check zone to make sure that I didn't botch where that goes. It loaded up. So we can do our NDC.
It's the same serial number though. Is it really going to change?
It is,
Damn serial number.
because I have an audience.
No, because we've all been trapped there and it had the same problem for how many times?
We've seen this movie before.
Yes, exactly.
Right, so now
Why won't this thing change?
name server records and our MX record go away. No, MX record will have 60-second TTLs and our www will have 5-second TTL.
What's the 0 do there?
So MX records you can, oh, yeah. That red is
There's no zero there.
Yeah, there is. Watch.
Oh, there it is.
So, MX record has, or MX has the concept of a null MX record. You can say, I don't want mail at this label to ever arrive. I don't know if anybody knows the order for MX, or for mail delivery lookups. First to system checks, mail sending system checks for an MX record existing. And if that MX record doesn't exist, then it looks up the A and quad A record and tries to deliver mail directly to
The IP.
to the IP address of the label that you're asking for. So if somebody tried to send mail to Mitch at nsnyc.bbtab.org or .com in our case, it'll see that there's not an MX record, and then my mail sending agent will attempt to deliver mail to these IP addresses. So we can craft null MX records to instruct, and this is actually just great practice to get into. For every host that you don't ever want to receive mail for, and any host that you don't want to send mail for, right?
So this way it won't fall back to the IP
It
address.
will fall back to the IP address.
It's just
Right, you can do, you can also.
Oh, it won't fall back because it finds an MX?
That's right.
Okay.
The RFC is very specific that it has to be priority of 0 with a single dot returned. I suspect that almost all implementations will accept any MX value, right? You probably shove a 10 there just fine, level 10 or anything else.
So it's the 0 that
But
does it?
it's the dot that does it. The dot's the magic that says there's not an MX.
What's the 0
MX records are listed in priority. So if you have 5 mail servers, you might have them listed in priority 0, 1, 2, 3, 4, 5. So when you enter an MX record, you have to give it a priority. Our priority on this
Like a
MX
sequence
record is
number.
0. Yep.
What if there's two with the same MX priorities, like two different name servers have the same priority set?
The sending mail server gets to decide which one to use. You'd hope that there's some level of round robining. I've found from the couple small mail servers that I've ran that regardless of what priority you put in there, somebody's going to send mail to all of them. They don't follow order. I just kind of a little small mail tangent. If somebody tries to mail my 99th, my furthest away mail server, the one at the lowest priority, the highest priority, the one that you should never mail to, I just assume that they're a spammer and tell them as much and make them try again. So I grade list the people who send me mail to my other mail servers. So anyway, you can do the same thing, right? You can do I think it's SPF B1 equals no all mail, right? You can set the same thing for sending. You can set an SPF record that says I'll never send mail from this label. Same like the MX record.
Well, that's for outgoing mail.
That's right.
Yeah.
That's for outgoing mail. So you can set an MX record for inbound, a null MX record for inbound mail, and a what's essentially a null SPF record for outgoing mail, and that'll help prevent people from spoofing one of your other domain names. We see a lot of spoofing happening where people will take, where everybody will have a well-crafted SPF record for their domain name, but they'll leave all of their subdomain names, all of their sublabels without an SPF record, and they'll have, president at www.merit.edu send mail, and the receiving mail server, right, should look that up and say, it doesn't have an MX record, it never sends before, the parent has an MX record, but the reality is that doesn't happen. So if you ever want to spoof somebody and make it kind of look legit, you can probably get most mail receiving servers to accept mail for child domains in that same company. And it looks pretty good to the end user.
Mail dot.
Yeah. Well, so there's a lot of companies that will have like an M dot, right? An M dot
Like mobile
Google.com for their mobile. And that's really hard to see, right? When your mail's coming from president at M dot google.com. It looks good.
Of course,
Why
the
wouldn't
president's
the
using their mobile server.
Right? Why wouldn't? Yeah, most users don't know. So I'd get in the habit of setting an OMX record and an SPF record for every single zone you have.
So does the subdomain have to exist in order for them to be able to spoof it?
I would hope so. No, of course it's up to the mail receiving server to do its level of spam checking and SPF validation. I
So
would
there's no
hope
way
that-
to say only accept the ones that I've specified and ignore all the others, or?
So that doesn't exist. If you really wanted to, you could make a catch-all label. Bind will happily extend this sort of notation and apply this for absolutely every zone. So you could do
So if
foo
you,
and bar.bbtap.com, and this wildcard will expand out and deliver this.
So all the names in it.
Mail should never be coming from bbtab.com,
Right.
unless specified otherwise.
Unless specified otherwise. Yeah.
so it goes from top down. So if it's already defined, it will, or does the order matter?
Nope, order does not matter in your zone file.
Okay.
The order matters as the zone file is getting read into the machine. This record, this quad A record, is still at the one above it, the label above it, the most recent label. That WW is all the way up. So it's only when it's read in, and then bind will treat a wildcard as anything else that it doesn't know about. But I don't think I would ever go down this path. I would expect the inbound mail server to do some reasonable checking to see whether a domain exists.
Would that cause
Because-
extra overhead?
Only that you're responding to every record,
Okay.
Instead of offering back an NX domain. But it really gets crazy at that point, because then do you go further to do, something like this? Right? Do you need to do the wildcard of the wildcard? Right? Do you need to, how many levels deep does this go? So I don't play that game. But there's a DNS way to solve every problem. Everything starts to look. When DNS is your hammer, everything.
Yeah, everything looks like a nail.
Everything looks like it.
Yeah.
Yeah. So, I think there's a question.
Yeah, I mean, to shoot it off topic, what do you think of Cloudflare? Have you ever used Cloudflare?
Oh, Cloudflare is a very reasonable web application firewall, layer 7, if you want something to watch everything that's happening. It gets that job done very well. They leverage DNS. They leverage being a DNS host to deliver web application firewalling. I don't love it or hate it. It's I don't know if it's any different than having a Palo Alto or up-to-date, whatever the latest layer 7 firewall is somewhere else. They do an excellent job about delivering packets fast, caching. Their cache service is great. I think it has its use case. Definitely worth reading to see if you agree or disagree with their engineering and policy choice of hosting all traffic without hesitation. They don't. Most hosting providers won't host things that you and I would consider bad. Cloudflare will host anything at all in the entire world. They consider themselves just a proxy service, just a transit provider, and they'll host bad. So there's kind of some weird gray political stuff there. But if you're interested, I can share my opinion afterward. Gets the job done for caching the layer 7 firewall.
Sort of the same question about what kinds of tools would you suggest we take a look at for managing domains? And I'm in a position where I'm managing a messed up environment, and I don't have access to change domain records. So I have names that, just were used at some point, and I don't know if there's some way I can change the name that's in DNS without having the actual DNS access rights. Does that make sense?
It does. So you can't necessarily change them. Just ask for them to be changed to something reasonable. We can use the www dot example here as we talked last time about using DNS to define both service names and machine names. And DNS is a great way to do that, where you might have your machine name be something like my web server, right? Web server 00. Right, it hangs around, it has the A record of the IP address for the person that's responsible, or the machine that's responsible for serving that traffic. And then you'd have your www service record, which would be your CNAME, to web server 1, or web server 00 in our case. And I find this to be an incredibly straightforward way of separating services, and the machine to machine and the people name, right? www is going to stay the same no matter what, no matter how many times I move that machine, no matter what building it's in, no matter where it goes. And then using a reasonable machine name to describe the actual IP address of where that service is running. This can further be expanded into the responsible party field, and we'll have to check the syntax, but I think that you could even list group names, or you can ask your DNS infrastructure teams to list group names and email addresses and actually standardize on a record that tells you who's responsible for that machine right in DNS. You can even make up your own text records, right? To actually put information about what runs web server 00. And then someday when web server 00 moves on, right, it's got a new IP address, it moves to a new machine, you're trying to reconcile all of this. Ideally, right, you're going to go update your CNAME record to point to the new machine, but you can keep adding CNAMEs to keep discovery available. When that server moved, where did it move to, and who's responsible for it now?
May I have your attention, please? The time is now 8:30, and the
So
library
this
will be
is,
closing in 30
I
minutes
work a
at
lot
9 p.m.
in this sort
Please be advised that the internet will
world
shut down 10 minutes
where,
before closing. Thank you.
my service name, whether it's 0MQ or my master database or my web server or whatever it is, has a service name forever dedicated to it. And that's what goes in your machine-to-machine config files. That's where your humans go to look. And then that's always linking to the current server. That's always just going to point its name to the current server with its A record. And then for the cases that you miss, or while you're transitioning to that new architecture, leaving CNAMEs behind for somebody who remembers, yeah, there was once a machine, web server 00. What was that? What did it do? Leaving a CNAME behind, pointing it to the new machine, is a nice reminder of what machine is now managing that service. Eventually aging those out as they get too old or something along those lines. But responsible party records, like an A record or a quad A record, live right in DNS, and it allows everybody inside the organization to query who's responsible for that machine, whether it's a group email address or something else. And that works both in forwarding and reverse records. So I hope that's kind of a cool,
Okay,
Yeah,
so
good.
that looks like something that people who have access to the domain server can do.
can put in, yep,
Yeah.
but then the whole company can access that information.
Okay, so the question is, if you don't have access to the domain server, this is totally something that can't be done, and can't. So I'm thinking of some kind of tooling or something that will allow, information about the environment to be available, much like the domain name service stuff is. So, you know, I'm thinking, do I have to spin up my own domain name server in my environment, or?
Yep.
Okay, all right.
Yeah, if you want this data to live authoritatively in DNS, you've got to put the data in DNS. That said, if you're responsible for a subset, let's say we had a mail group, right, in our fictitious organization of bbtab.com has a mail group that's responsible for all of the mail servers. We can give them their own subdomain. Right, we can do the mail folks can have their own NS server. And then, right, if you can get your master DNS folks, the guys who run the top level domain for your organization, to put 2 NS records in for you, then you can run your own DNS infrastructure to capture all of your own information. So everything, you know, web.mailfolks.bbtab, this would, in essence, delegate everything underneath mailfolks to you. So you can keep delegating zones further down, which creates nice organizational boundaries, so that things don't have to be made at the highest level of an organization every single time. This is really common with, well, it's common in all sorts of scenarios.
I think we're having all call time.
Okay, yeah, sorry.
Thank
Yeah.
you. Yeah, that was a giveaway. Yeah.
Great, thank you.
So please fill out your comment cards